Okay, we're going to look at problem 27 out of section 11.2 in your textbook. This is page 665. And we find that Kelly Drossler borrowed $3,500 from a bank for 6 months. Her friend Miss Harris was co-signer of Kelly's personal loan, and the bank collected 7.5% simple interest on the date of maturity. So what I've done here is written down the pertinent information that we have from the text that we just read. Principal is $3,500, the time is 6 months, and the rate is 7.5%. And we're instructed to figure out what rate of simple interest. Or at least we notice that we're dealing with simple interest. The 7.5% is a simple interest problem. So that should clue you in to the fact that we are going to use in part A the simple interest formula, I equals PRT. Now, when you're working with this formula, one thing that has to be true is that the units that R and T are both in need to be the same. So if we go back up here and look at the data I've written down, our time is 6 months and the rate is 7.5%. Now, it doesn't say what type of interest rate this is, and so we are to understand that this is an annual rate or a yearly rate. So right now I have a yearly interest rate and a monthly time. So I need to change one of these to be in the same units as the other. The easiest one for me is to take 6 months and say, well, that's 1/2 of a year. And so now I can plug the numbers into the formula to answer the question for part A, which is how much did Kelly pay for the use of the money? I equals 3,500 times 7.5% times 1/2. Putting this into the calculator, you're probably going ahead and changing 7.5% to 0.075 and 1/2 maybe to 0.5, and then it's easier to put in the calculator. Type all that in and you will find out that the interest is $131.25. And that's the answer to part A. Part B asks us to discover the amount she repaid to the bank on the due date of the note. So the way simple interest notes work is, unlike other loans, you're not making regular payments. She just went in and borrowed the $3,500 on the first day of this loan, and then 6 months later she will go back and pay the interest as well as everything she originally borrowed. So she's going to owe the original $3,500 plus the interest of $131.25 for a grand total of $3,631.25. And that's the answer to part B. This is problem 28 out of the text, same section 11.2, page 665. We're told that Kwame Adebele borrowed $2,500 for 5 months from a bank using U.S. government bonds as security. The bank discounted the loan at 8%. So once again, I've written down the pertinent information. This 8% is a yearly interest rate because we're not told otherwise. So therefore, I'm going to change the time to also be in years. 5 months is 5 out of 12 years. It's 5/12 of 1 year. So the part about how much interest did Kwame pay the bank for the use of its money, which is part A, is simply a simple interest calculation, I equals PRT. So we plug in $2,500 for the principal, 8% for the rate, and 5/12 for the time. If you put all this in your calculator, you'll find that I is $83.83, and that's the answer to part A. Part B says how much did he receive from the bank, and this is where the fact that the problem is dealing with discount loans comes into play. With a discount loan, you pay the interest up front. So if he's going to owe $83.83 in interest, $83.33 in interest, he will take the $2,500 he wants to borrow and immediately pay the $83.33 out of that. So the amount that he will actually receive from the bank and take home would be the difference between the principal and the interest. So $2,500 minus $83.33 is $2416.67. That's the answer to part B. Part C asks what's the actual rate of interest he paid. Well, the actual rate of interest is from his perspective. From his perspective, he didn't really borrow $2,500 because he only got to take home $2416.67. Yet he still paid $83.33. So what simple interest rate would be charged if you borrowed this amount and paid this much in interest over 5/12 of a year? So we go back into our formula, I equals PRT, plug in for the interest, 83.33, the principal of $2416.67, because from Kwame's perspective, that's all he got to take home. The interest rate is what we're going to try to figure out, and the time is still 5/12. Now, when you're working with this problem, you want to be careful here. We're solving for R, so the easiest way to do this is to go ahead and figure out what the right-hand side of the equation is. What is 2416.67 times 5/12? I'll leave the left-hand side alone. So if we multiply these two pieces together, we get $1,006.95, and we've still got R. Now you actually get a whole lot more decimal places than this. So it's actually better off if you were to keep all of those decimal places, such as I've got right here on my calculator. 1006.945833. You don't want to round in these problems until the very end if you can help it. So if I go back to the equation, I'm trying to figure out what R is. So I've got this number times R, so in order to get R by itself, I divide both sides by that number, but I'd really rather not divide by the rounded answer. So I want to divide 83.33 by this entire expression over here. So if you still have this number printed out on your calculator, you can type 83.33 divided by, it's a nice feature of your calculator, you can do second answer, and it will divide by the answer you got in the previous entry without you having to round, and we get that value. So according to my calculator, R equals 0.082755 and some other stuff. This is supposed to be an interest rate. So move it 2 places, I get 8 point, let's round it to 1 decimal place, 8.3%. And that's my rate of interest that Kwame really feels like he's getting charged because it's a discount note. Okay, lastly in this section, we're going to look at problem 56 on page 667. It states that on August 31st, 2007, Trinity Lopez purchased a 364-day $6,000 U.S. Treasury bill at a 4.4% discount. So our principal is $6,000, the time is 364 days, the rate is 4.4%, and I've got this date of August 31st, 2007. The first question we're asked is, what is the date of maturity of the Treasury bill, given that 2008 is a leap year? So the first thing I need to do is go to my chart, which is found on page 662, which lists all the days of the year in numerical order, and I can find out that August 31st is day 243. So my job is to figure out what date is exactly 364 days later, because that's the date that this Treasury bill will mature. Well, I know, or at least I can figure out, how many days are left in the year 2007. I know there's 365 days in that year. I'm on day 243, so 365 minus 243 gives me 122 days. So there's 122 days left in 2007. and then we're going to carry over into 2008. So how far into 2008 do I need to go in order to have the entire 364 days elapse? Well, if I've used up 122, how many days do I have left? Take my 364, subtract off the 122, and we get 242 days in 2008. So I need to know what is the 242nd day of the year 2008. According to my chart, I can see that day 242, if you look on the chart, find 242 in the middle, you can see that day 242 is August 30th. Now that's true in a year that is not a leap year. Because it's a leap year, there's an extra day in there for February 29th. So the 242nd day is not August 30th. In leap year, you actually get to day 242 on August 29th. And that's the answer to part A. You get there one day earlier because there's been an extra day involved. Okay, now moving on to part B. How much did Trinity actually pay for the Treasury bill? So here's the way Treasury bills work. What you're doing in essence, when you purchase a Treasury bill, you are giving the government of the United States a loan. You're basically serving the role of the bank, and the government is the one borrowing the money. So it's kind of different in this problem, thinking of yourself as the bank, but that's what's going on. So when it says how much did Trinity actually pay for the Treasury bill, the first thing we need to know is how much interest is the government going to pay. So if we look at our formula, I equals PRT, the principal is $6,000. The interest rate is 4.4%. And then the time, well, we know it's 364 days, but we've got to be in the same units as our interest rate, so I need to turn 364 days into years. This is where the use of the banker's rule comes into play. Anytime you're using the simple interest formula, the days you treat as a portion of a year that has 360 days. So yes, I know that a real year has 365 days in it, but when using a simple interest formula, you apply the banker's rule and your denominator becomes 360, not 365. So these are all the numbers we have. We plug them into the calculator and we get the figure of 266.93. That is not the answer to part B, but we need that number in order to answer part B. Part B says, how much did Trinity actually pay for the Treasury bill? Or another way to phrase that is, how much did Trinity loan the United States government? Well, because it's discounted, she doesn't give the government $6,000. She gives the government $6,000 minus this interest because it's discounted up front. So we take the principal value, subtract off the 266.93, and we come out with 5733.07. So $5,733.07, and that's how much she will pay for the Treasury bill on August 31st, 2007. Part C is now really easy to answer. Part C asks how much interest did the U.S. government pay Trinity on the date of maturity. The answer is this value we already found, 266.93. Because again, the way this is going to work, on August 31st, 2007, she's going to pay the government $5,733.07, essentially giving the government a loan. 364 days later, on August 29th, 2008, the government's going to pay her $6,000. So she's going to have earned $266.93. She's going to get this money back plus $266.93. Lastly, Part D. What is the actual rate of interest of the Treasury bill? So the stated rate was 4.4%, but she's actually going to be earning a little more than that. So we've got our I equals PRT. From the government's perspective, because they're the borrower, they paid an interest of $266.93 on a principal of $5,733.07 because the government never really had the $6,000. The interest rate is what I want to figure out, and the time is 364 over 360. So we get 266 93 equals, multiply these two numbers together, you get 5796.77 and a bunch of other stuff times r. And so if I want to get r by itself, divide both sides by this number. Again, you want to use your answer key on the calculator. So you would have multiplied, let me put this up here for you, 5733.07 times 364 divided by 360. And that's where you have the 5796.77 and a bunch of other stuff. I want to divide 266.93 by that answer. So I'm going to use second negative sign to divide by my answer, and I get 0.04604. So let's write that down. R equals 0.04604, some other stuff. This is an interest rate, so move the decimal 2 places, and we'll get 4.6% is the actual rate of interest that the government experienced on this discount note. So that's how you do discount notes.